let's talk about intents and what Anoma does with regards to Ethereum with an intents machine. Brief recap, what is actually a VM? It has an instruction set, as a program counter, it has different layers of memory. Generally speaking, programs that run sequentially. This is really the model that we've known for ever since Ethereum came up, because the predominant and the first model to really implement this is the Ethereum virtual machine, right? The Ethereum virtual machine is it's a specific VM, but it's fundamentally a virtual machine. In comparison, what is actually an intent machine? And here it's important to understand that an intent machine isn't there to replace a VM. It is a different layer of abstraction on top. It is something that you can run on top of on top of a VM, or on top of some specific execution environment. So an intent machine, it takes a batch of intents, computes valid possible state transitions, selects one according to some criterion, and updates the state system. Here the criterion is fully user definable. Intents are just, at least in sort of what Anoma's doing with regards to generalized intents, intents are just arbitrary code. They are whatever you want them to be, whatever you can program. And they don't exist yet. So the first one here is really the Anoma resource machine, which is the first generalized intent machine in existence. I want to have a brief sort of detour here on the fact that Anoma is an interface. It is not an intermediary, and this is very important to understand. I'll sort of go through why. So, what are intermediaries? Intermediaries are generally actors in the network, so there are specific parties that you interact with. This may be a single key, this may be a blockchain, but there are specific parties that you connect to, like you know which counterparty, which intermediary you're interacting with. And this position gives them the ability to extract rent. They will add to your security model. They are actual things you need to consider within your deployment stack, like within your user stack, that you are now relying on this intermediary. This is not just an interface. And sort of the best example right now in Ethereum is many bridges in the ecosystems are intermediaries, pretty much all of them. And here it actually doesn't matter whether it's a multi-sig bridge or effectively a large multi-sig that is run by a validator set. These are fundamentally intermediaries that you must add into your trust model, right? You are specifically interacting with that party. In the real world, actually, one of the best examples here is banks. Banks are fundamentally intermediaries. You have to end up trusting the banks in order to access the system. And so as a result, they can even charge fees and things like this, or freeze your funds. And this is all true with regards to bridges at the moment as well. On the other hand, we have interfaces. And interfaces are protocols which translate or represent one semantics of ordering, compute, storage, and so on, of an underlying machine. They are just code. They are freely copied. They are very different to intermediaries, right? You do not have to interact with a specific counterparty. As long as you interact, or as long as you sort of adhere to this interface, you can connect and talk with anyone else that adheres to the same interface. In the real world, one of the best examples here is TCP/IP. And here sort of the distinction becomes very obvious, right? That in order to connect to the internet, not all of us have to talk to the same Oracle server run somewhere in New York. As long as you implement TCP/IP, and there are many implementations in many different languages, you can handwrite your own. Honestly, TCP/IP is not that complicated. If you're dedicated and have like 2 weeks time, you can probably implement your own TCP/IP stack in the language of your choice. You can talk to anyone else that implements this, right? And it's a very different model. It's a model where every central server can go away, and it still works that two people in this room use the interface to talk to each other. This is very different to the intermediary case, where if the intermediary goes away, you cannot use that service anymore. Here, this is just code. You can change it, you can modify it, you can do whatever you want with it. You can re-implement this from scratch. It doesn't matter. And I just want to stress this because the Anoma protocol is a protocol for declarative intent, imperative ordering, compute, and storage semantics of underlying machines. It is just code. There are full specs for this. You're free to copy this. You're free to modify this. If you want to implement this in many different languages on many different virtual machines, please go ahead. This is to say that there's no Anoma chain. There's no Anoma chain to which you must send your intents in order for you to leverage Anoma. You can just use Anoma deployed on Ethereum without ever interacting with any specific Anoma chain. You're just interacting with the interface. You're adhering to the interface standard, right? And yeah, sadly, I think this point really, interfaces versus intermediaries, really gets overlooked quite a bit in the current world, where I think a lot of people assume they're interacting with an interface, whereas in reality they're interacting with an intermediary. So whenever you use anything on chain, actually make sure which one of these two categories you fall into. Intermediaries are fine, you should just know about it. Yeah, so Anoma, it's a universal intent machine for Ethereum. This is really sort of the simplest way to say this. Anoma does something that just adds extra capabilities to what's currently possible in Ethereum. It provides a generalized abstractions for universal or generalized intents. Yeah, so what does this actually mean? It means that builders can write dApps in terms of intents instead of transactions or execution traces. And here, this is a very important difference, where currently everyone is writing applications, or users interacting with Ethereum are interacting at the transaction level, right? Like, as a user, you're currently signing over a specific execution trace. You don't actually sign over a specific state change, you sign over a set of opcodes that can modify the state. Incidentally, this is where a lot of the MEV comes from, that the fact that if I have an execution trace that I've signed over and someone else has an execution trace that they signed over, depending on how you interleave them, you get to different state outcomes, right? Like, this is sort of fundamentally, they are not pure in that sense. With intents, you are writing in terms of state updates. You're writing, I currently have state B and I'd like state, I currently have state A and I'd like state B. And the system can figure out sort of, is there something to actually like provide the inverse, or B to A, or is there maybe 500 people that sort of, if you take all 500 intents combined, then sort of this balances out. So intents really, as a builder here, you can start writing your applications in terms of partial state transitions that may or may not get sort of solved for, rather than fully fledged state transitions that are immediately executable on chain. Yes, so a lot of people think about intents and they think limit orders. And this is technically correct. Limit orders are a very specific kind of an intent, right? But here, what we're really talking about with Anoma and the Anoma resource machine, it's Anoma implements general intents. Whatever you can write down in code, whatever state you want to express, you can express it using Anoma. You're not constrained to any kind of specific intent. So you can use sort of these generalized intents to build limit orders, sure, but you can also use this to decentralize something like a Gitcoin DAO, where individual users end up having individual votes. We collect 500 of them, then those 500 intents get combined into a fully fledged state transition that is then actually executed on Ethereum. Interesting enough, intents also just generalize rollups, because when you think of what a rollup does, right? A rollup is, you have a state transition from A to B, someone else has B to C, and so on. And then the rollup collapses the entire thing into A to D or whatever. Intents just generalize this model. Yes, and this is really important, actually. Intents and dApps written, sort of adhering to the Anoma protocol specification, can be ordered, solved, and settled on Ethereum. This is, with Anoma, you get an entire P2P stack in order to enable, for example, decentralized counterparty discovery and distributed solving. But fundamentally, if you care about the security model of Ethereum, go ahead. You can just settle to Ethereum here. Yeah, so in summary, Anoma is a universal intent machine for Ethereum. Intents and dApps written with Anoma can be ordered, solved, and settled on Ethereum. And interesting enough, if you're really into distributed systems, come find me later and we can chat about sort of generalized sequencing. But the consensus behind Anoma is called Typhon, and it generalizes shared sequencing, which enables you to, now that you have intents, you can not only settle on Ethereum main chain, you can also sort of in the intent specify what rollup or what specific security zone you care about. Maybe you want to specify that you want to settle on Ethereum main chain because this is a security model you care about. Maybe you want to say that, well, I want to be on an EVM rollup, or I want to be on even a non-EVM rollup. It doesn't actually matter here, or something like an eigenlayer AVS. So really, the pick is yours. This is really important to understand. Like, the intent machine here, it's an abstraction, it's a high level of abstraction that makes it possible to build applications that were not possible to be built before, right? Like, it is something on top. It is not something to try to replace existing infrastructure. It is just to make the developer experience and the user experiences more expressive. Oh, actually, what's my time? Great. So yeah, let's talk a little bit about intent-centric dApps on Ethereum. And why use Anoma to build dApps here, actually? What affordances are provided? You get permissionless infrastructure, as in you do not have to talk to a specific counterparty in order to be able to use the system. You can just gossip your intent to 2 of your friends, because those are the only people you trust, so you can gossip them multicast to the rest of the world. This is really up to you. The topology of Anoma is not defined in the architecture. And this is, I think, something that most protocol architects are currently doing wrong to a large extent, that it is very difficult, or it's impossible within an architecture to define the actual deployed topology of the system. Right? The topology of the deployed system, as in which node connects to whom, is purely dependent on user and operator behavior, as in who chooses to interact with whom. And Anoma goes to great length to make the architecture completely topology agnostic, so that the actual users, the actual economic flows, can form the topology that they care about. For example, you can build a topology that is optimized for latency. And here one example is that if 3 people here want to sort of locally trade some, I don't know, ETH for Bitcoin or something, like genuinely intense, the obvious thing to do is that we locally connect over fiber optics with each other to order and solve these intents, and then settle them on Ethereum if we all care about the Ethereum security model, right? Like, it makes no sense that each of us talk to a server halfway across the world in order to do the counterparty discovery and solving part. So this is what I mean by permissionless infrastructure. You get intent level and intent machine composability. So intent level composability simply means that intents aren't application specific. So I have an intent, for example, I want to go from state A to B, and I'm sending this to the network. Someone else may, and a simple example is I want to trade. I want to trade ETH for Bitcoin. I do not have to specify on which specific dApp or exchange I want to do this. I just go, this is the state transition I would like to achieve. And then other people may have completely different intents. They may be wanting to trade in a different security model or in a different setup, but those intents can still compose, because in the end, intents are just sort of declarative models of, like, I have state A and I'd like state B, and as long as someone else has B to A, or something like someone else has B to C, and then there's C to A, you get this intent level composability. The other nice thing is you get intent machine composability. And what that means is, rather than treating every single rollup in the ecosystem as a separate system, you can just interact with the intent machine and say, well, I would like to settle to, I would like the security of this specific rollup. So rather than treating, you can treat a network of distributed machine or distributed systems as a single intent machine, rather than as many different disjoint intent machines. You also get information flow control. And really this comes to the point that, and I think most people don't realize this yet, but so in the current world of blockchains, we all work with a large piece of globally mutable state that is readable and writable by everyone that sits in the middle of the system, right? As soon as we want to have anything with ZK, state moves to edge devices. As in, state will move to your local edge device. And you as a user end up having the choice here, what kind of information do I actually want to reveal? You can reveal everything, you can reveal only what you want to do but not who you are, right? Like, information flow control is fundamentally going to be important because it maps better the model of where the state is actually going to live in these systems. As in, state mostly lives on local end devices rather than sort of in the middle of the network where everyone has to sync this. This is also way better from a scalability perspective, because rather than having all state live in the middle, and like now all nodes have to sync all state, we can have commitments to that state, and the actual state, the underlying data, never has to be shipped across the network. It just resides on edge devices, like your phone, your laptop, whatever, and you choose what actually to publish into the rest of the network. And you get this idea of heterogeneous trust. And I think this is going to be actually very important, because trust is very subjective. Not everyone will want something that's globally decentralized, right? Like my parents, for example, they want something that's locally secure. They want local sovereignty because they trust their local community. If you live in, I don't know, maybe Argentina or somewhere like this, you may actually really not trust your local security. In that case, it's very valid that you want to make the choice to go into the globally decentralized thing, right? But the important thing is with Anoma, we don't pick the security model. Sort of, as a user, you can individually pick, do I care about local sovereignty? Do I want to use a globally decentralized system? The architecture does not constrain the topology here of what is possible. Yeah, so let's go through, I think, 4 examples of what kind of novel dApps can you build using Anoma on Ethereum. Great. So public signal. This is effectively the inverse, and this is something I'd very much like to see. This is the inverse of Kickstarter, where rather than being supply-side driven, right, Kickstarter is very supply-side driven. Someone goes, I think a lot of people will like this idea, then they publish, they sort of supply this idea into the market, and then if enough people come together to actually have demand, then this may happen. Public signal is the inverse of this, where a lot of individuals can start signaling with intents using cryptographically signed intents, the idea that they would like X to be done. And now we can start sort of seeing what is their demand for, and rather than sort of supplying something and hoping that there will be demand, we can rather listen to the sort of the intent gossip and go, oh, there clearly is some demand here. Now let me try to build this. And the nice thing is, for example, if you had something where you need at least, I don't know, 10 ETH or something. So like 100 people come together, everyone provides some ETH. And so if you publish this as demand, as soon as someone is capable of supplying the other side, they can take those 100 intents together, create their own intent that provides the supply side, and then settle this immediately and make this executable on chain. This is sort of the thing I'm most excited about at Scale-Free Money. It's the capability to effectively issue mutual credit lines. So rather than rely on centrally issued currencies, we can use scale-free money that I issue my own currency, and only my like social network will trust my currency, right? But sort of instead of all having to route via the central currency, we each issue our own, and then I can do credit clearing with people that I trust. And sort of over time, you can start expanding this network that if I'm trying to transact with someone that I'm not directly connected to, but there's a hop along some path in my social graph, we can still transact. And I think this is sort of a very cool idea that is especially useful for smaller economies, because it allows smaller economies to sort of like really bootstrap their asset without having to rely on sort of everyone has to route via USD. You can directly route via your own currency. I mostly think about this in the case of Switzerland, where at Switzerland you can issue local currencies, as in like there's a cooperative that there's mutual credit clearing in Weir or something. Weir, I forgot the city name. But so there are some attempts, but I think really Anoma provides here very scalable infrastructure using intents to actually enable scale-free money at scale. You can build multi-chat. It's an actually decentralized version of Discord, because again, intents are arbitrary. They may be financial in nature, they may be carrying financial assets, they may be carrying ETH, but they may also be just carrying data. There's really no distinction here between, I think this is actually an important point regardless, there's no distinction between like information and assets. I think in the digital world, a lot of these things are collapsing onto each other, where using intents, you can just build a very cool chat application that, where sort of the topology of the network is defined by who's actually talking to whom, and who wants to trust each other with their data. And then you can use build something like a promise graph, which is simply a system for organizations to not be bound by specific team boundaries, but to rather like let the organizational setup reflect the actual work being done. And this is something we're using internally, which is very cool. So we are dog fooding the promise graph to build Anoma, which is nice. Yeah, if you are interested on like jamming on some of these ideas, there you go. It's a QR code to research.anoma.net. So, let me see. All right, great on time. All right, TLDR. VMs and IAMs aren't compatible, aren't competitive. They are just a fundamentally different layer of abstraction. they allow you to do something else. You should care about interfaces, not intermediaries. Using intermediaries is fine. You should just be very aware that they add into your trust model. They're not just an interface. Yeah, what does a universal intent machine mean for Ethereum? It means that you can build intent-centric dApps. You get a standard for intents. And most importantly, you can actually settle on Ethereum. Again, on the affordances, you get permissionless infrastructure. You get intent and machine level composability. You get a large amount of information flow control, which I think is going to unlock the next wave of applications, actually. And you get this fundamental idea of heterogeneous trust. Yeah, and then we spoke about some ideas for novel dApps on Ethereum. There. If you have 2 hours or 3 hours, maybe, ideally your entire flight back, check out this post that my co-founder Chris wrote on Anoma as a universal intent machine for Ethereum. It is dense, but it's very worthwhile because it explains all of Anoma in a very understandable way. So if I went through some of these concepts way too fast right now, this also has all the links to sort of the underlying background material with regards to cryptography as well as the distributed systems part. So yeah, please check it out. Yeah, this was it. Thank you very much.
All right.